So we're going to use our prime factorization that we did yesterday to find what's called the greatest common factor, or GCF. I'm going to show you an algebraic way to do this because sometimes your numbers aren't always small enough for you to just kind of be able to sit there and think about, okay, what number divides into whatever. But before we get into that, I want to, like, when I'm talking about factors in general, there are several factors for 10, right? And generally, when we talk about factors, we talk about factors other than one and itself, but that doesn't mean that they can't be used as factors. And then let's say there's 1 times 20. Those are both factors for 20. 2 times 10. Those are both factors. 4 times 5. So I've got all the factors listed for 10. I've got all the factors listed for 20. So what we're looking at here is when we're talking about the greatest common factor, I want the biggest number that divides into both of my other numbers. So I want to know the biggest number that divides into 10, the biggest number that divides into 20. Now, there is more than one answer here, right? For a factor. 2 is a common factor, right? That covers that, common is then they both have it in factors and it divides into both of them. But the greatest part, there is only one greatest common factor. Now for 10 and 20, it's relatively easy to see which one is the biggest one. I'm more concerned about when we're looking at bigger numbers that you don't know the factors as offhand as you do for 10 and 20. So this one, there was 3 different factors, but there was only one greatest factor. So the way we're going to do this is we're going to do our prime factorization like we did yesterday, and then we're going to construct our greatest common factor out of these prime factorizations. Okay, so I'm going to kind of fast track this a little bit. I've already got my factor trees done and my prime factorizations for my numbers done. What I'm concerned with us doing now is being able to construct the greatest common factor out of these things down here. So for us to be able to list something as part of our greatest common factor, it has to physically be in each of these prime factorizations. What I mean by that is 7 is not going to be part of my greatest common factor because there's no 7 listed over here under 9. And I can't list more of a factor than is physically represented. Now, what I mean by that is, there's 3s over here under the 9. There's 2 3s under the 9, as a matter of fact, because it's squared, but there's only 1 3 that I can account for under the 21. So for me to be able to put anything down as a factor down here, it has to be common between both numbers, and it has to be a factor. It has to divide into both of them. So I'm not going to list anything down here that isn't under both numbers in my trees, and I can't list more than I physically have represented in a number. So I can't put a 3 squared down here because there isn't a 3 squared under 21. I can't list a 7 because there's no 7 under the 9. So the greatest common factor for 9 and 21 is just 3. What that means is 3 divides into both 9 and 21. There's nothing bigger that divides into both. Okay. And again, for the first one here, I picked kind of small numbers, so it was easy to kind of do in our head. Some of the bigger ones, you're definitely going to have to do a factor tree on these. 36 and 24. I picked these specifically because they have multiple factors. So I've got the prime factorization for 36 is 2 squared times 3 squared. The prime factorization for 24 is 2 to the third times 3. So my greatest common factor, I'm going to piece that together out of these guys down here. Okay, so whatever I put down here as part of my greatest common factor has to be here under the 36 and also here under the 24. So I've got 2's that I can put down here because I've got 2's under 36 and 2's under 24. And as a matter of fact, I've got multiple 2's that I can put down here. So I can bring down this whole 2 squared, but I can't bring down the 2 cubed because of there's only two represented over here. I can't pull down this third one because there's not enough there. So I'm going to pull down 2 squared. So I'm going to have a leftover 2 here. I don't care about that. And then I'm going to have to bring down a common 3. Now I can't bring down a 3 squared because there isn't a second 3 here under the 24. So my common factors are 2's and 3's. So my greatest common factor is going to be 2 squared times 3, which is just 12. Okay, again, I've already got this factor tree done, so kind of the same thing. Greatest common factor is going to be made up of 3s and 5s. So I've got a single 3 that they have in common. I can't bring down more than a single 3 because there's not more than a single 3 here. And then a single 5 for the same reason. I've got a single 5 here. I've got a 5 squared here, but I can't pull down a 5 squared because there's not a 5 squared under 45. Greatest common factor is 15. All right, 95 and 135. The only thing I'm going to be able to pull down for my greatest common factor is that single 5. There's no other factor. There's no other common number under 95 and 135. Whatever you pull down as your greatest common factor, you need to multiply back together to get your total greatest common factor. So that's why this one was 15.